Let's take a look at how we can use Google Sheets to value a bond. Now, there are a lot of ways to value a bond. You can use a financial calculator. There are programs to calculate them in Google Sheets. But I'm going to show you a couple of different ways. And part of the reason I'm going to do it this way and use Google Sheets is that it allows you to get an understanding of the changing of interest rates and the price of the bond. If you just use a financial calculator, you don't really see what's happening there. So this is a great way to practice using Google Sheets as well as to get a better understanding of the bond valuation process. The beauty is that if we put the formulas in instead of just a bunch of numbers, we can change numbers here and see how it affects the price of the bond. So the first thing I want to do is I want to figure out what the cash flow is. So I've given you the coupon rate and the par value. The coupon rate tells us the percentage of the par value you get each year in interest. So you're going to get 6% of $1,000. So we're going to put in this cell here, and I'm going to hit the F4 key. That locks the cell. I really only need to lock the row. So in front of the dollar sign, it locks the column. I'm not copying across to the right, so it doesn't really matter. Times the par value, and I'm going to hit the F4 key again. And you can see you get $60 in interest. Let me expand that to 2 decimal places so you have the sense. And I'm just going to copy this down. I'm going to copy this down. So each year you get $60 in interest, and then in the final period you also get back the par value. So that's why I have 2 5s here. So I'm just going to put this in right here. And if we want to figure out the present value, we could use the formula or the present value factor, which is 1 divided by 1 plus the interest rate, which in this case is the yield to maturity. It's the yield to maturity that changes. The coupon rate stays fixed. And I'm going to hit the F4 key because when I copy it down, I want it to stay on cell B4. And I'm going to raise this to the power year. So number 1. So this is the present value factor. And the beauty of Google Sheets is it tries to figure out what we're doing, so it actually wants to autofill this. If it's correct, we can just hit this check mark. If it's not, we can hit X and type it in ourselves. I'm going to hit the check mark because this is correct. And let me just adjust these decimal places so it's a little easier to see. So let's see. That should be enough decimal places. So the present value of the cash flow is just going to be the cash flow times the present value factor. So I'm going to type in this times this. And again, it wants to fill it in for us. If you don't want to use that, you can simply highlight the cell, and then you see that little box on the bottom right. And if you just hover over it, you get this sort of plus sign, and you can just hold the left mouse key and drag it down. So we get these values. Let me expand this decimal place here. And we can just sum this up. Okay, so let's put a label in here, bond price. And let's do that. So here I'm going to go over here. If your toolbar looks like this, if you hit these dots, you'll see this summation sign. That's for functions. And it gives you some of the functions. Well, we want the sum function. I'm actually in the wrong cell. I want to be in this cell, so let me do that again. I'm going to hit sum, and I'm just going to highlight the cells that I want to sum up, and I add it up, and I get $1,000. Why did I get $1,000? I got $1,000 because the yield to maturity was equal to the coupon rate. Let's see what happens when the interest rate goes down. So let's try 4.5%. What happens? The price of the bond goes up. So let me highlight that so you can see that a little better. Interest rates go down, bond prices go up. Okay, let's try 7%. Interest rate goes up, bond price falls below the par value. This is a mathematical fact. Okay, it actually happens. If you own a bond and interest rates go up, you're going to see the price of your bond fall. So let me show you another way to do this. Instead of calculating the present value factor, you could just calculate these present value, each cash flow's present value, and then sum them up. And you can use the PV function in Google Sheets. Again, we're going to put the rate in, that's the yield to maturity, and again, I'm going to hit the F4 key so I can lock that cell. And the number of periods is going to be what year we're finding the present value for. Payment amount, this is an annuity, okay? We don't have an annuity here, or we don't want to use the annuity function. I'll show you how to do it with an annuity function. So I'm going to put in a 0 here, and the future value is and there's no par value either. I'm sorry, the future value is this amount. So you can see we get the same values, right? And let's just let this fill in for us. Okay, it filled in for this one. We just want to sum this again, and you can see we're going to get the same values. They're just going to be negative, and they're going to be negative because when you use these functions, if you have positive future value, you're going to get negative present value, and vice versa. So you get the same value. And let's do it one more way. We could have used the PV function because this is an annuity. Okay, so I put 0 in for the payment amount, but we could have used the PV function again, and we could have said the rate again was this. Okay, I don't have to lock the cell because I'm not going to copy it anywhere. I can say the number of periods is 5. And I'm going to say the payment amount is the 60. Okay, they're all the same. That's an annuity. And the future value is the par value, and I could have used this one too. And I should get the same value here, again, 959. And again, I've put formulas in, so if I change the interest rate to 3%, we see that all these prices change. So this is a nice way to do it. So let me show you one more thing you may want to do. I did this with annual coupon payments, so yearly interest. It's quite common to get semi-annual interest. So let me just copy this information over. So we'll do the same thing we did before. And this time, I'm going to assume semi-annual interest. So in this case, instead of having interest paid every year, you're going to have 2 interest payments. You're going to get half that amount twice a year. So we're going to call this semi-annual payment. So there's going to be 10 6-month periods in a 5-year bond. So what are the cash flows? Cash flows are going to look like this. It's going to be equal to this coupon rate. Okay, I'm going to lock the cell with an F4 times the par value, and again I'm going to hit the F4 key, divided by 2. So you get $30 every 6 months in interest, as opposed to $60 once a year. And let's just copy that down for the first 10 periods, and then the final period you just get back the par value. Okay, and now we do exactly the same thing we were doing before. For some reason let me see. Let me copy this. There we go. All right, we'll do exactly the same thing we did before. Okay, present value. Let's just use the present value function so we don't have to calculate the present value factor, and then I'll show it to you in using the present value factor to do the whole thing, or the present value function to do the whole thing at once. Here I'm going to do each individual cash flow. So I'm going to say equals PV the rate. Again, yield to maturity is the rate. Lock the cell. Oh, wait a minute. What do we want to do? If you're going to get interest every 6 months, this is an annual rate. We have to divide that by 2. And the number of periods is going to be equal to this. We've already doubled that, so we have the number of periods. That's no problem. And here we have no payment, right? We're just going to use the future value amount. We've already adjusted this, and we get this amount. And let me just let it autofill for me. And then again, I can sum this up. Auto sum. And enter, and you'll notice we get a slightly different answer from here. This one's $1,137.39. This is $1,138.33 because you have different compounding. So slightly different answer when you have semi-annual compounding. And if you want to use the PV function and account for the annuity, again, same thing, 3%. Lock. We don't have to lock the cell because we're not copying down. Divided by 2. Number of periods would be, in this case, 10. So we use this number. The payment amount, or the annuity, is the 30. And the future value is 1,000. And if I've done it correctly, I should get the same answer again. So these are several ways to do it. You may have ones with, questions with annual coupons. You may have questions with semi-annual coupons. When you have semi-annual coupons, you're going to have twice as many periods. So I actually shouldn't have put years here. I should have put periods. And the yield to maturity is going to be half the amount. Because this is 3% per year, it's going to be 1.5% every 6 months. So you can do it both ways. Several ways to do it in Excel, but again, in Google Sheets. But a good way to see how changing interest rates impact the price of the bond, right? If we have the same yield to maturity as coupon rate, we get a price that's equal to the par value. So this is a great way to practice a little bit in Google Sheets, but also to get an understanding of how, when interest rates change, bond prices change too.